Okay, now for this one, it's going to be a little bit different. So let's go for domain first. I always like to start with domain. So with this one, you'll notice that I can't reduce my function. So that means that there is no hole, there is no removable discontinuity. Now, so again, finding the domain, set the denominator equal to 0. Now, if you're getting to the point where you can do this in your head, that's great. So I can look at this and say that x cannot equal -1. Okay, so that means from previous work, I know since I can't simplify it out, that I'm going to have a vertical asymptote at x is equal to -1. Okay, so let's see what happens. So, next thing I should find is probably an x-intercept and a y-intercept, yeah? So let's try to find an x-intercept. Okay, remember when you find an x-intercept, you set your y equal to 0. Let's see what happens. So again, we're going to cross multiply. So 0 times x plus 1 equals 1 times 2x plus 1. So now that side goes to 0, 2x plus 1. If I solve that, you will notice that I actually do have an x-intercept for this one. So that's kind of nice. So if I solve it, I get -1/2. So that means I have an x-intercept at -1/2. All right, let's go ahead and find the y-intercept. Remember, when you find your y-intercept, you set the x equal to 0. So your y-intercept is 1. So I have -1/2 comma 0 for my x-intercept, and then 0, 1 for my y-intercept. Okay, let's see what happens when we graph. Get my ruler. Okay, and then I got to put in my vertical asymptote, but I don't have a hole to worry about, so whoops. Okay. All right. So there's my vertical asymptote, there's my graph. So I've got -1/2. Oh dear. So that's right there. Okay. And then 0, 1 for the y. Okay. So don't really have a lot to go on. So what I'm going to do is I'm going to just start plotting points. I'm going to start plugging things in. So let's start over here to the left of my vertical asymptote. So let's see if I plug in a -2. Oh, my brain just... Let's see. So 2 times a -2 plus 1 divided by -1, +3. Okay. All right. And then if I plug in like a 4, a -4. Oh, wait. Yeah. Let's plug in a -4, see what happens. Oh, I get a +2 1/3. like that. Okay, if I plug in, let's say a negative 10, let's see what happens. I get negative 2.11111. So let's see, that's 4, that's 8, that's 10. So it looks like if I go further out, I notice that no matter what I do, I never quite make it to 2. Okay, I'm going to redraw that curve. Okay, so what this is implying, oops. Okay, what this is implying is that I actually have a horizontal asymptote. It's just in a different spot this time. Okay, the first couple times it was at y equals 0. Here it's somewhere else. It looks like it's almost going to be at y equals 2. So let's try the other side, see what happens. Okay, so let's plug in like a positive 10, see what happens. So that would be 21 divided by 11. That's 1.9. Let's see, 3, 6, 9, 10. So about right there. And let's go a little bit further in. Let's plug in a 5. So that would be 11 divided by 6. 1.8. So it almost looks like no matter how big I go, and I realize 10 is not a very big number, but I can't quite make it past that barrier of y equals 2. So it looks like for my end behavior, what happens is x approaches negative infinity, y approaches 2. As x approaches positive infinity, y approaches 2. So that would imply I have a horizontal asymptote at y equals 2. All right, now, so let's draw that in, just so we have it there to see. So this graph is a little bit different in that it has both a horizontal and a y, or a vertical asymptote. Okay, so that does happen. Now let me show you a little shortcut as to finding those kind of asymptotes. Okay, just really quick. And this will be a little bit quicker for you than, maybe doing it, thinking of it as x approaches infinity and negative infinity. Okay, so what you do is you look at the degree. Oops, numerator. And denominator. Okay, so first case. All right, if the degree of the numerator we'll call it degree of n, degree of d. Okay. If the degree of n is less than the degree of your denominator, then your horizontal asymptote is y equals 0, automatic, no questions asked. Okay? All right. If the degree of your numerator is equal to the degree of the denominator, then your horizontal asymptote is y equals the lead coefficient over the lead coefficient of the denominator. Okay, so let's go back and take a look at what we have here. Okay, the lead coefficient of our numerator was 2. The lead coefficient of our denominator was 1. Well, guess what? Our horizontal asymptote turned out to be 2 over 1, right? Okay, so if the degree is equal, and for this one, h of x, the degree on the top and the bottom is both 1, your lead coefficient divided by your lead coefficient is your horizontal asymptote. Okay? All right. Now, if the degree of your numerator is greater than the degree of the denominator, okay, then we have what's called you don't have a horizontal asymptote. Okay, you have a slant or oblique asymptote. And in our next video, we'll get into those. Okay, so again, several videos, going slow, see how it goes. Okay, all right, we'll talk about slant or oblique asymptotes on our next video.